All right, welcome. We are on part two of our Java inheritance control, and we're gonna yeah, we're gonna have fun with it, of course. What I'm going for is the mouse rollover assignment that's from your book that we're kind of completing and also extending. What I want to do now is I want to complete the part of the assignment where we put our cursor over the image and it changes the image view's image because of the cursor being over or inside of that region. So that means I need an event handler, and I need an event handler that will trigger when the mouse is hovering over the image view. Now, event handlers within your like mouse event handlers can be kind of tricky, much trickier than like keyboard event handlers. And the reason why is because of the different regions that you're dealing with on the screen. And I'm going to kind of give you an idea on that. I'm not going to use Java terms. I'm going to use generic terms for, if you apply this to other languages, it's kind of the same idea. Especially with controls and forms and form-based type applications. And the issue being is that when you have a form, you have several different windows in your form. You've got your main window. Oops. Okay. Well, that's a horrible square, but that's okay. And then let's say we have our little image here and our other image over here. And then we have like a group that we're putting this guy in. So when you are dealing with controls, this is getting out of hand. Let's do some better squares and boxes and whatnot. You've got multiple places on the screen that you are dealing with X and Y coordinates. So I'm just going to use this example without adding more to it. Let's say that this is our window, and we click here. And that would be 0, 0 is up here in our window. So that would be an X of probably about 300 and a Y of like 20. If we clicked here, that would be an X of probably about 20 and a Y of, let's see, down, that's probably about 22. But so you see, clicking here, we get a coordinate of 320. So we're actually referencing the coordinates of the screen behind the images. And when we click here, we could get a coordinate that represents the screen coordinate, or the coordinate that represents where you clicked on in the image, because the image has its own 0, 0 start. So depending on what you click on and where you're dealing with your event handler and your bubbling, it can turn into a real snafu. But it's actually really quite easy to do if you do it the Java way, which is inheritance. You should inherit everything. And everything is just super object oriented. So just remember that. Sometimes your coordinates may be based on the local object that you're working with instead of the whole screen. And there's different ways of grabbing an X and Y when we deal with mouse coordinates. And we'll see that as we progress. So yes, I have some code that we're going to be using for this, and our first step is just to get that mouse over going. And we're going to do it with inheritance, because that's how we started this whole project, is by inheriting a control, which is the way you should be doing things for every control you have. I'm going to be using controls in here that are not inherited, and that's just to show you something very quickly. And I'm talking more your project here, not your assignments, guys. Some of your assignments, you don't really want to go through all the trouble of inheriting a text box or an image view or whatever, but your project, if you are wanting controls that have the same look and feel, inheritance is the way to go. Because you can just literally set those attributes in what you inherited from the actual code that you're working with, which in this case of what we're dealing with is called GPiece that inherits from ImageView. So what we can do here is one method of event handling that is discussed in your book, and that is by using inheritance. And the reason why this is so beautiful is because it uses the dynamic binding. And what's happening behind the scenes is there's always a loop kind of running behind the scenes in your application. It's just kind of going, and it's looking to see, hey, did something get clicked on? Oh, look, this guy got clicked on. What should I do? Well, it's an image view. So let's call the image views click event or whatever. So essentially that happens at the base level when you click. So that click event gets charged up at that base level. So that means that the code that you are using at the application level and it's calling that. It's calling it from its base. So it's code that you didn't write, but they know that maybe there might be a click event that is being handled for that application. Well, the same thing is for regular controls. It's always got a loop that's looking behind the scenes for not just this, the application control, but for the image view control to see if it's been clicked on. If it's been clicked on, then it calls the event handler that's supposed to handle it. And here's the beauty of it. The work has already been done. They already call the function for you. All you have to do is put the silly function in to handle it. It's already done. It's beautiful. They call it at the base level. And they expect you to have that event in your code so that, you're doing the contract like you should, but so that you can grab a hold of that particular event when needed. And that's how form-based technology works for all languages, because the issue here is giving this technology to somebody, but also giving it to them with authority or alacrity, I guess, is because you have full control with it. It's yours. Okay, enough of that. Let's get to writing some code. But that's another reason why I talk about dynamic binding as being extremely important. So all we have to do is add an event handler, and that's in our code bits. So let's just do the one and test it. And the one that I'm looking for is it's going to be in our GPiece code. And guys, this is definitely not code that you want to get greedy with. We're going to be doing this a little bit at a time. And by the time we're done, we'll have something that you'll enjoy. So let's get into the events that we're gonna be setting up for our game piece, and that is going to be in the code that we have for the G piece. And I believe that is it right. Okay, guys. I'm gonna have to pause because evidently I copied my code bits wrong. Don't worry, you guys, your code bits will be fine. I'll be right back. Okay, so I got the code. We're ready to go. We're going to implement the event handler for the game piece. I am in the game piece object right now. And what I'm going to do is just add the event handler that is called at the base level so that I can override it and implement it. So the one that I want is obviously probably because the one we're doing is the mouse rollover. So we want an event that fires when the mouse is hovering over an image view, any image view. So we're actually adding an event handler for all image views here. And there goes the next value of inheriting Java controls. is that not only can you make your controls specific, but look specific, but also behave specific with functions and events. So the piece of code that we're looking for is in your code bits for part 2. And we're going to be at the top, and we're going to be looking at the G piece code bits. And the bit that we're going to want is the event handler, and we're not going to get too greedy here. Let's just do this one, these two, and we'll discuss them. We're going to do, actually, let's just start with the one. Let's just start with the one. That's the way you want to do things. You don't get too much code in at once, guys. Get a little bit of code in and then test it, you know. So what I'm going to do is I'm actually going to embed this into the object itself as an overridden function. And the override is for the mouse entered. Now notice we're applying the event to this. Since we're inside of GPiece, we're applying it to the image view itself. And then next, we're going to assign for that mouse event, when the mouse enters our image view, we're going to give it the handle or the function of what to do. And that we're embedding in here too. So now we have an event that fires. And let's just go ahead and comment that out for now, and let's see if we can't get this to compile. And it looks like we may have some issues with some includes that we don't have. So let's go ahead and deal with that. I don't know, maybe there's some more syntax issues in here, but let's get into the G piece code. And it looks like everything we need is right here for G piece. And it looks like mouse event is the one that we're missing. So we're going to go ahead and go up to the top and put that in below your package. Okay. So now I have a few things. I'm going to be using the event handler of the JavaFX library, the mouse event. I'm also going to play around. We're going to play around with an alert just for fun, because we're going to change our nice little image view, our customized image view, into a button, a really fancy button. And then we're going to have it move around the screen and do stuff. Okay, so now I should have something that's getting closer to being able to compile. And I may have copied or pasted this in wrong. Let's give it another look and see if I'm missing anything. Okay. Yep. Because it's an embedded function. So we got to actually embed it into runtime. So we got to embed it into some kind of runtime with the piece. So since we are mostly using the overloaded constructor, I'm not going to put this into the default. Just know that you should put it into the default, and it shouldn't be embedded like I'm doing. What you would want is to have an event handler class that you instantiate. Well, you know what? This is pretty fine for, it's okay to do it this way because it's fairly regimented. I would rather, inherit from event handler and then set up this function so it's outside of the game piece. So because what the problem is if we have it embedded in here, we're stuck to this. Well, actually, it doesn't really matter because the big issue here is when the mouse event fires, we have no idea what game piece it fired on. It doesn't know that because it's just a function that's running out there on its own, in its own scope, waiting for that event to fire. And it has no knowledge other than what fired the event. Okay, so that's a really huge deal there.
What day and time?
Okay, it looks like Alexa's having issues right now. I'm going to tell her to be quiet. Be quiet.
For what time?
Oh my goodness.
Sure. As a Prime member, you now get Amazon Music's full catalog of million songs.
Yeah. Pause for comedy now, please.
Shuffling all my goodness and similar songs on Amazon Music.
All right, I'll be right back, guys. Okay, we're not going to have Alexa playing music for us anymore. So the problem with this is when this event happens, I don't know what game piece was clicked on. For all technologies, no matter what, the event that you're dealing with is always going to run in its own scope, and so it's not going to have awareness of your variables and your values. It doesn't know that, you know, when it fires this event, it doesn't know particularly. You're not actually programming in the scope of where you have variables you can work with. And the thing with an event handler is what they send you, always with this technology, is the thing that actually initiated the event. And when I say thing, I'm talking about an image view, a text box, any kind of control. So that's the beautiful part about it, is the event handler itself sends you the piece of data you need, which is what you clicked on or what your mouse is hovering over. So all you have to do is know what is what is actually creating that. And what we're going to do is to get that target is we're going to create a game piece. We're not going to instantiate it. We're just going to create a temporary game piece, and it's going to be assigned to the event handler's target, which is the image view that instigated the actual event itself when the mouse was entered over that particular image view. And then we know what image view we need to set the image of for a new image. So we have a string up here called fImage and a string called bImage, and we're going to load that image up, the different image up, when we enter. Before we do that, let's just do this. Let's just test this. Let's just look to see if something is actually working. Okay, so now you see where I'm doing my mouse is over it, but you see down here in the console, mouse entered, mouse entered, mouse entered. It's all outputting right here. Okay, it's working. So that means then that we are going to take, and this is how you do it. If you know what object is being targeted, you get your target from the event handler, and then you cast it to what it's supposed to be. And you know what it is, so it's going to work. You know it's a game piece because you wrote the code to do it. But here, I mean, this is so nice because all we have to do is just add this silly function. That's all we have to do, and it is automatically called at the base level of ImageView. We don't have any other things that we have to manage for this event handler. It's just so nice. Now, let's go ahead and create the game piece, or create the reference for the game pieces, that game piece that we get from the event handler. And once we have that reference of the game piece that the event handler actually instigated, then we can actually implement the new image. And there's our image change. Well, hey, it's just another little step to go ahead and say, hey, we need another event handler. We need one that says on mouse leaved or on mouse exited. And that one's right here. So we're going to embed this in the constructor also. Okay. Now this is for when we exit. And what we want to do is we want to, when we exit, we want to take the game piece image that we exited from, and we want to set it back to the face image. Whoop whoop. Okay, this takes us to pretty much what was needed for the mouse rollover assignment. Here's what I want to do. Let's make this into a fancy button. Why not? You know? Okay, so let's go ahead and add that. So what we want is we want a mouse pressed. And then we're going to do something when the mouse is pressed. And what I want to do is I want to pop up an info box. And the info box is just going to say something when the mouse is pressed. But let's get the code for that input box. I've got the mouse press code in. The info box is just something we're going to throw in there. And we're just going to put it somewhere quick and easy. Did I take it out of the code? Yeah, I wanted to show the info box, but that's fine. Evidently, we're not going to do the info box. We could just do a regular alert, but I don't want to take your time. What we could do is... oh, yeah, you know what? Let's just do the alert. No. Let's just do this. Mouse pressed. So what we could do is when the mouse is pressed, we can pretty much perform any action that we want. So you see here, we got mouse pressed popping up over here. So essentially, we just changed this into a fancy button. We could do something funky and set the X and Y values to the one that you clicked on. You know, hey, that's great. You can do an alert here. It says, ouch, don't hit me anymore. Something like that for a game if you want. And if we really wanted to change this into a game, we would do some more like, hey, doesn't a game piece need to be able to be moved on the screen? I think it does. Well, guess what? There's an event for that. It's called the mouse drag. Now, what's really cool about this is usually I'd have to build this myself, but they actually have it already built so that you know if the mouse has been clicked and the button is being held down and the mouse is moving. And that's what it triggers the mouse dragged event for the image view. If you click on it, hold it down, and then move the mouse. Usually I'd have to set up some booleans and detect for the mouse click and set the boolean and detect for the mouse move. And if the boolean was set, then move. Yeah, okay. Yeah. So this was really pretty cool to work with because you just have to put it in and it detects when you are, when the user is doing a drag operation. What is the user doing a drag operation on? Well, the target of our what we click on. And then what are we going to do? Well, if we're dragging it, let's click on it. Let's get the mouse coordinates from the mouse event. And let's make sure we differentiate the right X and Y coordinates. We want the scene coordinates, not the image view coordinates. And let's set the image views X and Y. So that every time that we hold down and drag the mouse, it moves with the mouse. Yeah, that's why this technology is so popular, because you can do cool stuff real quick and easy. Now you're saying, oh, Mr. B, why is it snapping to? You see how it kind of snaps to? See, it's kind of going to that X and Y that I'm setting it to. That's because you need to set an offset here so it doesn't snap. And you actually have to use a previous X and Y mouse value. So you guys can play with that if you want to fix it. There's other ways of doing drag and drop, for JavaFX that you can also look into. Or you can just fix the offset and have your own little drag and drop. And that's, I've done it before. It takes a little while to, work your way through the logistics of fixing that little offset. But hey, remember, if you want to do it, you have to use the previous value, the previous X and Y mouse value to be able to make that happen. Okay, we're going to go ahead, and we're not really doing much of anything for the mouse pressed. Let's take and extend this even further. And why don't we do an input to add more of these guys on the screen, and also let's have them bounce around. The last thing we're gonna do is let's have them moving around. Let's do the input first, so that we can add. And I'm gonna actually give you an assignment challenge that you can take in lieu of that you can use as part of this video series. So let's go ahead and get into that. What we're going to do is have some kind of input, and that input, I've already actually created the code for you that we can bring in, and that's going to be in our regular start code. Now we're going to have quite a few controls to kind of get this going. So some of these aren't used. Some of these includes the VBox and the HBox are used. But we're going to go ahead and go to the part in the code that refers to the main frame, your main with your start function. And let's go ahead and duplicate the includes for that, and go ahead to our main and just replace all the includes except for the import of the G piece that we need. We're doing it here, there, so let's get rid of it, that one. Okay, because we don't need that. And that should give us most of what we need for the code that we're going to be working with. Now, the first thing that I want to do is I want to implement some randomization as a test to play. So why don't you guys go ahead and implement these random and just play with it on your own, just trying to set the game piece to a random place. Now you notice how I'm doing like boundaries, like, because my screen that I'm setting this up for is 800 by 600, and each game piece is 50 wide. So it's just an offset to make sure it goes on the screen. So go ahead and play with that. But what we want for what we're trying to do is going to be here. In our start menu. And in our start menu, we have quite a few things going on. So what I want to do is, let's just grab the whole thing. Well, no, not the whole thing. Just a little bit at a time. We're going to grab just the... we're going to grab all the way up to the set scene. We're going to be adding this stuff later. Some event handling to that later. So let's go ahead and copy that. And we will put that into our start method here, so that we can have the start of some kind of a user interface. And that's what I'm really pretty much working with. So let's get rid of everything else. We're going to keep this. Now, what I'm doing requires that the root, because I'm using the root, the group node, outside of the constructor or the start method, I need to actually declare it up here. I don't want to declare it down here. So to get this error taken care of, we're going to go to our code bits again. And you'll see here that I've declared some of my stuff, like declared root. So root will be declared up here at the higher, the object level, at the object scope. So let's grab that bit of code. C width and C height we're going to use later on. So go ahead and just grab that. And we're going to put that up here in the object scope level. Okay, it looks like I have group root set up. I have the ability to so I'm going to have I got a width and a height and the group root. set up. So that's just a group that we're putting our image views in. And then we put the group into the window and it draws. So we're first going to create a first piece, a second piece. Then we're going to have a button add and a button remove. As part of that, we're going to have a label for one of the buttons. And then I'm going to have a text input. Now we're going to call that G input. Now this is a very special thing that I wanted to show you. I wanted to show you over, inheriting other objects other than just the image view. So we're going to have an extra object that we add to this called G input. And all it is going to be a text field that we're going to inherit from. So let's go ahead and implement that code. And we're going to find that G input in our code bits here. I think it's in the middle. Here it is right here. So here's G input. It's only a very simple example. It's not much, but if you really wanted to make this text field specific to just you could set all the properties for that text field inside of your constructors and it would look the way you want it to. So I'm going to go ahead and add that G input class. And I'm going to go over here to, I'm going to add it to the same package as gpiece.java. So I'm going to go ahead and say new Java class, and we're going to call it G input. And I'm going to say finish. And I'm just going to paste over that code that I grabbed. That's our G input. It's nothing. It's just you inherit from the text field and that's it. You probably don't even need most of these. You can probably just take them out. So our G input is set up for our own text field. So we're going to have a text field called G input. And I need to import G input now. So I'm going to import gpiece test dot. Oh, you know what? We may need to. It may make sense just to give it its own package. Yeah, let's do that. I'm going to go back here and just. Oh, that's why we put it in the wrong package. So G, we got to go back to G input and fix this. Let's put it under gpiece underscore test completely now. And now let's go back and see if we've got it popping up. There we go. There's a G input. Okay. We have our text field set up. So I create a label and then I create a text field, text in quantity of the G input class. Then I do a horizontal box and I send all those controls because we're going to use them in this example. And I just do some simple set, padding. And then when I create the actual window in the scene and stage and whatnot, I'm going to send that horizontal box with all my controls. So let's see why this isn't compiling right now. And then we'll give it a test. It looks like I've got a constructor for G input that I need to look into. Oh, I forgot this. Sometimes I forget that, guys. It just, public. Okay, there we go. Compile your heart away. Thank you. Do what you're supposed to. Okay, now this is going to add our these items, the controls, and show them on the screen, and then we're going to play with them. Okay, so here's what I want you to do. This is going to be, I'm going to give you a little bit of it, but not all of it. So this is your challenge. The text input box, I want you to be able to put 3 and then add, click add, and then have 3 of the images pop up, generated. Then I want you to be able to click remove and just remove 1. That's your challenge. Well, your assignment is going to be to add and remove. I'm going to be happy if you just get the add working. But kudos if you get the remove. So get the add working for your assignment. I'm going to just do it so we add 1, not where we can enter 3 and add 3. So where we add 1, I'm going to implement the button event for these guys. And that's where this is a little bit different than your other way of doing event handlers. We gotta actually tie the attribute to the instantiated variable that we're working with after it's been instantiated, and then we can make take advantage of an event handler for, like, say, the button add. So what I'm going to do is let's go ahead and look at the code that we're going to be working with for the button add event handler. And we have to put in the event handler itself. And then we have to apply the event handlers. So what we're going to do is let's just go ahead and add both event handlers in here. And we're going to put it right in the start constructor, or the start function, excuse me. What we want to do is we want to do it probably right here. I want to do it before I show the scene. Okay, now these event handlers, we have to then apply to the button. So let's just do this, comment all this stuff out, because we're not there yet. We're not going to even get there for a little while. I'm having you guys do the remove on your own. I'm only going to show you the add. So first thing let's do is let's just see if the silly thing is actually even working when I click on it. So from our G piece, we have kind of a little bit of something that we can output. System print line. Let's do that. Go back here and let's just make sure that that is happening. But I know it's not going to happen unless we add these 2 lines for these event handlers, because we got to actually add those event handlers. We got to tie the event handlers to the actual controls, and that is done with these 2 pieces of code. And you're going to put that above the stage show right before the end or after you declare your event handlers. And what this does is we define the event handler, we tie it to a function that we want to happen. Or this is the name of the function that we want to happen. Or actually, we're putting the name of the function implicitly inside of it. This is the name of the event handler, and the function is implicitly part of it. So down here, we just say, okay, button, set your action. What's your on action, your on click action, and what is the on click action? Well, it's the event add handler. And the event add handler has a function embedded in it that runs when that event is handled. So what we want is we just want something that says button. I don't care about entered or whatnot. I just want something that says that we click the button and it's working. Okay, so you see it's working down here. We got a button add. Okay, now here's what I want to do. What we want to do is we don't want to instantiate. We're going to instantiate it. We're going to say, hey, give me a new piece. Give me a new piece. Let's see. Let's just steal this part. I want a new piece, and we're going to actually get this code above working eventually. But I want a new piece, and let's just put it at location 100, 100. And you know what? Let's have some fun. Let's make this 100 by 100. Because we built the game piece so that it can do that. It can size itself. It's awesome. So now, well, we got the game piece. Now we need to add it. Now the reason why I put root up here, is because if we put it up here, then this function has no access to it because it's not at the scope. It's not running at the scope of the start function. It's running at the scope of the object. So I have to put it at object scope. And that way I have access to it from the actual event handler for clicking the button. So in our start function, we put the root declaration up here. We still instantiate it down here. That's fine. We just want to be able to have scope level access to it. That way our event handler can grab a hold of our root, which is the group of where we are putting our image views, our game pieces. So we could just say, hey group, get your children. You have some children already. Why don't you add another child that is a game piece? And it does it. So that we're going to go down here, and all we have to do is add it, and it goes into that background loop that's always running, looking for all images and controls, and drawing them, looking if they've changed and anything. That's all going on in that background base level code. And they call it they call it observable. That's the way they say or not observable, but yeah, they say it's observable, meaning that when you change it, it will automatically change because of that loop that's always running around in the background looking for a change to any of its properties for the image view. And if an image view property changes, such as an X and Y being set, then it goes ahead and redraws it in the appropriate position on the screen. Okay, so let's go ahead and run this. Okay, let's add. Okay, that's cool. Okay, I'm adding a whole bunch now, by the way. The problem is they're just all kind of being stinky and in the same position, which I don't like. That's no fun. So let's do this. Let's randomize not only, let's randomize the X and Y location and the size of it. So what we're going to do is we're going to get rid of this bit. We're going to uncomment this and uncomment that and uncomment that. And this is what's doing my randomizing for fitting within the screen width. And this is doing my randomizing fitting within the screen height. I think that should be 800 by minus width. So that should be 800 and 600 minus width. Those are incorrect numbers. Then we're going to instantiate our game piece based on that randomized number within our screen for its location and its width. And since we're doing a square, I'm just using width and height as the same here. Then we add that to the thing, and let's get rid of this guy, and let's play with that. Okay, we add. Okay, your goal, you should put 3 here and say add, and 3 should pop up on the screen. So your first step, read text field input convert to int. So you got to convert it from string to int. For loop of input count, run the code below. So you're just going to do this. If you do it, if you have 3, just put this guy in a loop and run it 3 times. So look at your text field. Hey, does it have a number in it? If it does, convert it to an integer loop. Every time through the loop, add another child. Okay, so this is good. We have it working, but I'm not done having fun. We're going to go to a little bonus session here. And in this bonus session, we're going to take the game loop that we played or we had fun with from when I introduced you to JavaFX and Canvas. And remember, Canvas is on most technologies, Java, JavaScript, and C#, I know for sure. And you know, it's kind of a constant type behavior. So what's nice about this? Here's what I like about JavaFX and its controls. Not very many Windows Forms technology give you as much power over your interface and your controls and the ability to move things around on the screen and redraw them within the form type environment. So what I'm doing is I'm actually doing game type development a lot easier within a form-based type technology, which means it's more robust and more powerful. The ability for JavaFX to mix form-based controls and normal type movement in like a window, kind of Canvas type movement. So essentially it has the ability to perform things that Canvas can do, like rotating, oscillation, all kinds of stuff like that not very many other form-based libraries add. So JavaFX really is a good interface for a GUI because of that capability compared to other languages. And so we're going to take advantage of that. Yeah. We could go crazy and make them rotate towards the end, but there's only so much time we have in the quarter. So I'm gonna take a break, and when we come back, we're going to introduce a game loop, and we're going to start making these things bounce around the screen, and we're going to try to grab them and play with them and whatnot and just be silly. See you guys in a while. Okay, bonus session. We are going to have some fun with a game loop. All right, it's already done. We're going to introduce a timer into our project. And you're going to go ahead and go to your code bits and grab the timer that's inside of here above your stage.show of your start method. And we're going to grab that timer and we're going to use it to essentially move our stuff around, our image views around on the screen like it was a game piece. Or you know, whatever, you know, just for fun. Yeah. So what I'm going to do is I'm going to go to my main start method, and I'm going to add that handler down right here. I would rather kind of put it down here. I think I'm going to put it right there because that looks just better to me. And then the timer we're going to instantiate, and we're going to start the timer. Let's not call this game update because we're not really doing a game. Let's just call it update. And we actually have to build that function and put it in here also. So this timer is going to run when we hit start. And this function is what's going to be called. And in that function, we're going to call an update function that we're going to add here now. So we're going to go up to the update function. And the update function, we're going to have some more code that we have to do for our game piece to make it so that it can be a little bit more gamey. But the update function we'll get into, and then we're going to make it work. So let's go ahead and find it in here. It should be somewhere in here. There it is, game update. It's in the, it looks like I embedded it right into the object scope. Yeah, okay. So let's embed it into our object scope of our game piece and put it right here. Okay, so there's our function that's declared for a game update. And you notice here that what we do, and rename this update. Let's just go back to here real quick. All this is doing is setting up event handler, and this is going to fire every, as fast as possible. You can set it up to fire every 5 milliseconds or whatever. You can set it up to fire every second. And I imagine if you don't set it to fire at a specific speed, it defaults to the fastest speed possible, which is why I haven't done much with it. As far as setting the timer and how much it ticks per minute, per second, or whatever. You really want it to only tick 60 times a second, because the human eye cannot differentiate any faster than 60 times a second when you're redrawing your images and whatnot. So a lot of people like to throttle their game loops down because it's not wasteful. Let's go ahead and talk about this now. The goal here is that if I want to add to the children of the root, first I have to bring it up here so that the root is accessible from the update function. And then I create a node that is just a generic node that represents the children that are in that group, which are, in a sense, they're image views. So that's a base class, and what we can do is say, hey, is this node, that is the base class, or one of the base classes. And we can say, hey, is this node an actual game piece? Because node is a base class of the image view. And when we put those image views on the children, we put them in at the node scope. Dynamic binding, baby. It's just there. It's so prevalent in this language that you can't really develop without understanding it. And that's one of the reasons why we spend a lot of time on it at the beginning of the quarter. Okay, so I get my node, and if it's a game piece, okay, then let's cast it to that game piece, so then I could just do something with that game piece for each update. And so what this is doing is it's just looping through all the image views that we put into our root group down here. So you see we had our group into the horizontal box. It's going through all the children in the horizontal box, the text input, the button add, the button remove, the label, and it's going through all those, and if it's a game piece, then it will cast it and decide to update that game piece. And so that means that we have to have an update function for our game piece. And what are we going to do with our game piece when we update? Okay, well, that takes us into our game piece code. And what we're going to do is we're going to add the update function to it. But before we do, we got to add some special things to our game piece. We already have an X and Y value, but if we're going to make this move around, it should really have an acceleration and a velocity. So let's go ahead, and remember, this is just for fun. So don't get too wonky-eyed when I start bringing in acceleration and velocity. We're going to go ahead and bring in these variables. And these are going to be what we use to both instantiate a game piece and set its speed and how it's moving. So velocity will tell us that it's, tell it to move, tell it how much it moves per frame. Acceleration tells it how much it increases in speed per frame. So let's just set those to 0.0. And we're gonna actually set these variables in a new overload for our constructor. But what I want to implement now is the update function. So we'll come back. Now let's do the constructor first. The constructor makes more sense to do first. The only thing that we need in this constructor, and let's just look at the example code for this, for the game piece. If we look at the constructor, we have an update function for the game piece that we're going to put in. And then we're going to update the constructor. Well, maybe not. Let's see. I'm maybe getting ahead of myself there. All right, let's just get in the update and we'll go from there. Okay, so grab your update function. And we need to put this above. I always like to do things, if I'm using them, I put them above. And that's just good practice. And that's only habits. You don't have to do it in Java. That's just habits for other languages. Definitely have to do it in C. Okay, so this update function, what it does is it takes the width and height of the screen, and it looks at the X and Y value of your game piece and says, hey, is it greater than the width or less than the left-hand side or less than the side or the screen? Or is it basically, it says, hey, is the game piece off the observable or the window that we are able to see in our coordinate system? And if it is, changes the velocity to go in the other direction by multiplying by -1. If the game piece's Y is greater than the height of the window, then reverse its direction. Otherwise, add the acceleration that we have for the game piece, and we could add some forces to it. We could add a force to it outside of the class, which we're going to actually might implement. But then we say, okay, the new X coordinate of our game piece is based on the old X coordinate of the game piece and how much it's supposed to move in the X position per frame. 1.0, 0.5, whatever. And then, of course, here's the big piece. Always, you've got to reset your acceleration every time at the very end of your game update, because acceleration is intermittent. It does not happen all the time. It happens, it's the time between frames that you have no acceleration. There is none. And it really gets into some serious crazy thought processes on that in life in general, but yeah, whatever. Okay, so this is what we want for our update function, and we zero it out, and all our update function is doing is moving our image view around the screen. If it detects it's near an edge, it changes the velocity so it bounces off the edge. So that's the first thing. That's the next thing that we need for our game piece. And I believe that we're ready to instantiate it, but we have some things in the constructor that we need to add. So let's go ahead and look at the constructor for our game piece. And it looks like we are going to be greedy and grab it all and throw it in? No. Let's just grab this little bit and talk about it. Yeah. Let's grab that little bit, because I think there might be some things that we need to look into when we actually deal with this. All right. Let's grab this part of the constructor for your game piece, and go up here to our game piece constructor, and let's use the one that we're actually doing, not the default one. We're actually using the overloaded one, and I think everything in here is pretty close to the same, except for a few things. Looks like we want this, and then we want to set the X and Y, and then we set the velocity of X and velocity of Y to 0. We're going to actually probably set the velocity of X and Y when we instantiate this. So I think we're ready to give it a shot, because we instantiate it and it sets up the velocity of nothing. So let's just instantiate it now inside of our update function. Or not our update function. Our update function is just looking to update it. We got to instantiate it in our start function, which is part of here, where we actually add it based on the button add event. So what we can do now is the game piece, we can decide to specifically put it based on a random position like we did. But now what we can do is call a set velocity function. Now this is, we have to add this, but all the set velocity function is going to do is take some random numbers between 0 and 2.5 and decide how much that image view should move per frame. And it's going to be an X value of 0 to 2.5 and a Y value of 0 and 2.5 on how much it moves per frame. So we got to actually build that function so that our update function will behave appropriately. Our update function adds, if we look at our update function, okay, I don't want to look at it over here. Let's look at it over here. Let's find it. Where is it even? Our update function adds the node and tells it to update. And when we look at the update function for a game piece, we see that the update function for that game piece, every time through, it adds an acceleration. But also, it adds a velocity. So we can add an acceleration. We can add a force every frame as an acceleration, sort of like that. But the velocity is constant. Well, not constant, but it's a constant that can change based on the acceleration. That's the only way the velocity can change unless we set it specifically so that every frame it moves by one in the X position and Y in the other position. So once we set it to like 0.5, then that means that the first frame, it'll move 0.5, and it won't show on the screen as being drawn. Because when we draw on the screen, we're not dealing with doubles. We're dealing with ints. So always that 0.5 and change is changed and truncated into just like a 0. So if we have 1.5 and we draw it to the screen, it's actually only being drawn to 1.0 or just 1. But we want to move by less than 1 so that we can move between frames. And that makes it smoother. And that's why we use doubles. So that we can, hey, move 3 times between a frame, and we've moved 3 times, but it's only shown up on the screen once because of the difference between a double and a float value, or double and an int value. Let's not get too far into that. Let's get this going. Let's get back on track. So that velocity X and velocity Y is what we're going to set, because it's going to be moving and setting the X and Y by adding it to the X and Y of the image view, or our game piece. So let's go ahead and look for that update function. That's an update function for the game piece. It's not the update function for the actual. So we got to go to the game piece code. So we're going to go up to the game piece code and find our update. Where are you? Oh, we already wrote it. That's right. Okay, yeah. We just talked about it and we already wrote it. It's in there. It's yeah, whatever. It's the set velocity that we need, not the update. So let's look for the set velocity. There it is. Add acceleration. You guys might want to play with that. I just put it in there for you guys for fun. You can add acceleration and just see what happens. It'll zero out. So every time you add acceleration, it'll only be for that particular instance. But yeah, play with that add acceleration. That's a lot of fun. And read about that Nature and Code resource that I showed you, or Nature of Code. So let's go ahead and add this into the game piece. And we want it to be above the update function, because we're going to be calling the set velocity function. We're not going to be calling it from the update function. It can go actually below. You guys can figure out where you want stuff on your own. Because I would, definitely be doing things like fixing this kind of stuff that just drives me nuts. I just don't want to spend a lot of time when I'm showing you guys stuff. So this set velocity function is on our G piece, and all it's going to do is set that that VX and VY, which is how much that that image view is going to move per frame. So we have that now in there, and so when we do when we actually add to the group in our add button event handler right here, this set velocity will now work, and it's going to be randomized, and then we add it. Okay, it looks like we got a few things that I've got to fix up. And you know what? I think we're far enough along. I'm going to look for this error, and we're going to come back. I think I missed somewhere I messed up some closing braces. So I'm going to identify that, and I'll be back, and we will test this and have some fun with it. Okay, well, I found it quick. It's in the update function that I added for the GP's test, the actual application update function. I didn't finish closing out the for loop, or the if statement here, and the for loop. Okay, cross those fingers. Let's hope we got something that works. I'm going to, no, I won't dance a jig, but I'll talk about it. Okay, ready? Woo-hoo-hoo-hoo! We have smiley face snow! Smiley face snow all over the place. What kind of fun we have. Okay, so here's your goal for your part of this assignment. I want you to be able to put 3 in here, or 4, or whatever, and you say add. I want you to go up to, shoot. Don't put any limits on it. Have some fun. Put 100, 1,000, and 2, put 120, 12,000 in there and see what happens. See how it behaves and how good it is. But also play with that add acceleration bit. And hey, maybe this can be a little fun game, because you know what? I could just go all the way around in here and just kind of move these guys around and do all kinds of crazy stuff. Whatever, you know. That's the beauty of inheritance, guys. This stuff comes together so quick, fast, and works well. And that's why you want to inherit your controls as much as possible. And that's the whole reason for this video series. All right. Thank you. Bye-bye.